Hello and welcome to the next episode of EVM programming course. In this episode, I would like to talk about the hard forks. So first, let's talk about what hard forks are. So in traditional software development, forking means taking someone's code and working on it yourself and maybe create some different version that is based on it. And it is very similar in case of blockchain. So forking means that we are changing how the current blockchain is working. So we are basing on our previous state and how previously the blockchain was working, but now we are changing something. So for example, in case of Ethereum, we are currently at Cancun Hardfork, and it brings together different changes. However, you might also know that there is Ethereum Classic. The difference between Ethereum that we are considering Ethereum and Ethereum Classic is that a few years back, there was a huge hack called the DAO hack, the first reentrancy hack. And the losses at that time were, if I remember correctly, in thousands of millions of dollars. So the creators of Ethereum decided, okay, we will introduce the specific change that erases what happened at this specific block. It would erase completely from our world state what happened there, and we will consider that it never happened. So this was really controversial decision, and this is one of the first hard forks of Ethereum, really. And then we have this split, this fork between Ethereum Classic and Ethereum that we know now. Before jumping into hard forks, there are also soft forks. So the difference between hard fork and soft fork is that in case of hard fork, everyone has to agree to the change. For example, if a set of new improvements to the EVM is created, then every node has to update their code to have these new changes. If they are not, then there will be a chain split, because the part of the nodes that already updated to the new logic will run the new logic, and the other ones will run the old logic, and maybe there are some differences that would make both of them not interoperable. Apart from that, we also have the soft forks. Soft forks are updates that nodes can agree upon, but don't have to. They don't have impact on how the worldview is working. So in case of EVM, we most of the time, if not all of the time, have hard forks. I on the top of my head, I can't recall any situation where the soft fork was happening on Ethereum. I only know about the hard forks. Oh, maybe if you actually consider the protocol that is taking EVM and runs it as their own chain. So maybe you can consider that as soft fork, because maybe if they're of course using the same version of Solidity, but the chain ID is differing, but yeah, actually hard to tell. So the official hard forks of EVM are first, it was Frontier. That was the first version of Ethereum that was created. Then we had Homestead, and you can see here that it introduced changes to EIP. EIP is Ethereum Improvement Proposal, which are, for example, EVM update, adding delegate call, and some non-EVM changes, which were related to how the peer-to-peer protocol of exchanging information between nodes worked. Then, as I said, we have Ethereum Classic hard fork after the DAO hack. Then we have Metropolis, in which the Ethereum Foundation started to work about switching to proof of stake, because for many years Ethereum worked as proof of work, just as Bitcoin does. Then we have Serenity, then we had Berlin, and actually the oldest hard fork that you can use, for example, in Remix, as I remember correctly, this is actually Berlin hard fork. Then we had London hard fork, Shanghai, and the others, but those are the official ones. But now we have many L2s that are, as they call it, EVM compatible, but they are actually not, and they can be considered as hard forks of it. And actually, there's a great resource prepared by Juancito called Multichain Auditor, and it gathers all the information about how different chains are differing between them. And this is a great read. You should definitely check this out. I won't really go into details of it, but I highly encourage you to check it out yourself. I can give you some example just to let you know how problematic it may be. So for example, we have Aurora, which is EVM equivalent, and still like the 9 ones are the same as with Ethereum EVM. However, you can see that Aurora introduces way more. For example, exit to near and exit to Ethereum, that you can take your funds and either withdraw your funds to Ethereum from the Aurora, or you can withdraw them to near bridge. For example, in case of Arbitrum, if you get current block by the number opcode, you will not get the current Arbitrum block, but you will get the last L1 block that Arbitrum knows about, which usually lags 1 minute behind. And if you want to read it, you have to use ARPSys, which has its own interface, and you have to use ARB block number to get the block number of current Arbitrum block. And of course, basically every layer 2 that is EVM equivalent is not really EVM equivalent 100%, because they introduce some different logic, different precompiles, sometimes even pre-deploys. The difference between precompile and pre-deploy is that the precompile is compiled into the node. It is not being run in EVM bytecode, but is being run in the native code. So this, if this is Go Ethereum written in Go, the precompile is written in Go language. If this is Nethermind, which is used C#, the precompiles are written in C#. It all depends on the language that node is written in. And pre-deploys are contracts that are written actually in either Solidity, Yul, or any language that compiles down to EVM, and they are put at the beginning when into the genesis. So when the chain starts, it has these contracts deployed as specific address. And there may also be a lot of different changes. For example, in case of zkSync, there was an unfortunate situation because the thing is that zkSync has built-in account abstraction. So every account is smart contract, and that also means that even receiving an ether, because there is some contract being executed, and it takes way more than just sending the value to EOA. And for example, low-level transfer and send may not work, and they actually don't work in zkSync. So you should not take for granted that the code that works on one chain will work on different chain. You always have to make sure that it will. In case of zkSync, the problem was that actually the team of zkSync had their funds locked nearly 1,000 ether because they used the transfer themselves and they did not verify that it will work on zkSync. So that's all for today. I hope you liked it, and see you in the next one.